All right, team, today we're going to talk about our next unit, and that's going to be looking at the properties of exponents. So go ahead and download this PDF. It is just a handwritten PDF, but I think it'll kind of work. Things to take note of are just like the different colors. The green means that that's going to actually be the solution. So I give you the problem and the solution, and the whole idea for this activity is to go through and figure out what's really happening. So print it out and maybe just highlight it or something if you don't have a color printer, or just do something to emphasize the different colors that are on the sheet. All right, let's get started. I'm going to give you a little introduction here with exponents, and it's going to be pretty short and sweet. So we're going to have b to the n power. So just things to take note of here. B is going to be referred to as your base, and n is going to be the exponent. Now, what b to the n means is if you have something b raised to the n power, that means you're going to have multiple factors of b being multiplied together, and there's actually going to be a total of n factors of b. Now, I don't know what n is. N represents some variable, so that's why I'm just going to kind of draw out a few factors right there being multiplied together, and then I'm just going to draw my brace there and just say, hey, there's going to be n of those. So keep that in mind. We have a base, which is the big number, and the exponent is what's up in the subscript. All right, so for each of these examples, what I want you to do is identify the pattern, and I want you to prove and show why it's going to work. So for example, I'm going to tell you that x to the 5th times x to the 3rd is going to be equal to x to the 8th. So let's take a look at what x to the 5th is actually going to look like. If I were to take the time to write out x to the 5th, I'm going to have a total of 5 factors of x. Now, I'm going to write out x to the 3rd. So I'm going to write out 3 factors of x. Notice they are all being multiplied together. Now, how many total factors of x do I have? Well, let's take a look. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 factors of x. So x to the 5th times x to the 3rd is going to give me x to the 8th. Let's look at it for part B here. So we're going to have x times x to the 4th. So x, I'll just write, that's going to be 1 factor of x. We're really lazy right there. Think about the subscript or the superscript right there being written as 1. That means there's 1 factor of x. Now we're going to do x to the 4th. So x to the 4th would mean that there's going to be 4 factors of x all multiplied together. And then how many total factors of x are there? Well, there's 1, 2, 3, 4, 5 factors of x. So x times x to the 4th is going to be x to the 5th. So what I want you to look at is, what's the pattern for A and B? Well, if we go back to A and we look at that 5 and that 3, it looks like if we took 5 plus 3, we would get 8. And for B, if we took 1 plus 4, we would get 5. So our pattern for A and B is that you add the exponents when like bases are being multiplied. So like bases mean that it's going to be the same base. Both bases here were x. So when we're multiplying things together with the same base, we could go ahead and add those exponents together to simplify it. Let's look at the next one. So for C and D here, again, we're going to look at the pattern and we're going to prove or show why it's going to work. So let's take a look at x to the 7th. And we're going to divide it by x to the 3rd. So I'm going to do my work right below it. So x to the 7th would mean there's 7 factors of x. And then x to the 3rd would mean that there are going to be 3 factors of x. Now, when I have like factors on top and bottom that are being multiplied together, so notice everybody in the numerator is being multiplied and everybody in the denominator is being multiplied. Like factors, when you're multiplying here, are going to cancel each other out. So 3x's on top would cancel out with 3 factors of x on bottom. And then notice we have 1, 2, 3, 4 factors of x being multiplied together up top. So you're going to end up with x to the fourth. Let's check out the next one. We're going to have x to the fifth on top now. And we're going to have x squared on bottom. And we'll do the same thing. We have like bases here, so I'm going to cross out like factors of x. So one pair on the top and another pair on the top and bottom means we're going to be left with 3 factors of x. X times x times x could be written as x to the third. So x squared, or x to the fifth divided by x squared is going to yield x to the third. So our pattern when we're dividing things with same bases is we actually subtract the exponents. 7 minus 3 gives me 4. 5 minus 2 gives me 3. So when we divide things with like bases, we are going to subtract the exponents. Now let's take a look at E and F. So E and F are representing a different type of problem here. This is saying we have x to the third and we're going to take that quantity squared. Notice there is only one base. There is a base of x. So I'm actually going to write out x to the third. So there's x to the third, x times x times x. Now, if I square something, doesn't that mean I'm going to rewrite the exact same thing 2 times? I'm going to multiply it by itself. So I'm going to end up with x times x times x, and then times x times x times x. So this actually puts us back in the scenario that we found for parts A and B. So notice now there's 1, 2, 3, 4, 5, 6 factors of x. So x to the third raised to the second power is going to give me x to the sixth. Let's see how that's going to work for part F. Sorry I picked such big exponents here. So x to the fifth, let's write out what that looks like. So there's x to the fifth. Now, if that's being raised to the third power, that means you're going to multiply it by itself 3 times. And I'm not going to have enough room to put this on one line, so I'm going to have to add this to a second line below it. Now, I wouldn't want to write this out every single time, but a good tip or trick is if you forget what these rules are, you can always write out a small example to help you figure out what's happening, when you should be adding, when you should be multiplying, and when you should be subtracting. Because the rules themselves are not tricky, but it's when you get so many different scenarios going on, it's hard to keep track of, is this a time when I add, when I multiply, when I divide? Sorry, I got a little sidetracked there. Let's finish out this example. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So x to the fifth raised to the third power would give me x to the 15th. So our pattern here for E and F is that when we have a base raised to a successive power, we multiply the exponents. Okay, successive power means a power right in a row. X to the third raised to the second power. Okay, successive powers, so that's when we know we're going to be multiplying the exponents together. All right, let's look at G and F. So G and F start to get a little bit crazy here. So I have a quantity just like I did really on the last example, but there's now a lot of stuff in there. So 3x, y, z all raised to the second power. Well, you could think about it 2 ways. If it's something squared, that means you are going to be multiplying it by itself. Okay, there's going to be 2 factors of whatever that value is going to be. And then you can just kind of look and see what's going to be happening here. We're going to have 3 times 3, because big numbers will still always get treated like big numbers. So that's where my 9 is coming from. We now have an x times an x. So I have something with a like base being multiplied together. So we're just lazy and we don't put those ones there. So x to the first times x to the first would actually give me x to the second. And then the same thing is going to happen with the y and the z. So y times y, again, that's like y to the first times y to the first. That's going to give me a y squared. And lastly, with the z's, we're going to have z times z. So z to the first times z to the first is going to give me z to the second. So that's one way to think about it. You could just simply write out what's happening and then use your rules of exponents. The other way that you can think about it is everybody inside of these parentheses right here, so everybody inside of there is getting raised to the second power. So you have 3 getting raised to the second power, so the 3 squared is 9 because 3 times 3 is 9. I have x to the first getting raised to the second power. So again, that would be an example of a successive power. So that would be an example where we would multiply the exponents together. So 1 times 2 is 2. And then same idea for y and z. Y to the first raised to the second power would multiply those exponents together. So 1 times 2. Oops. I don't think I have an undo on this. And then last one is the z. So z to the first power raised to the second, z to the first power squared would give us 1 times 2, which would give us z squared. Looking at the second one, we're going to have 2x squared y to the fourth, that entire quantity raised to the third power. So why don't we try it that second method that we used on part G. So we're going to have 2 to the third power. So 2 to the third power means you're going to have 2 times 2 times 2, which is going to give us the 8. And then we have x squared raised to the third power. So this would be an example of a successive power. So x squared raised to the third power, we'd multiply those exponents together. So 2 times 3 is 6. So that gave me 8x to the sixth. And then for the y, we'd have successive powers here again. So y to the fourth raised to the third. 4 times 3 gives me 12. So there's my y to the 12th. Okay, so my pattern here, or what I could say for G and H, is every term, or everything maybe, we'll just keep it generic, everything gets raised to the exponent. Now let's look at I and J. So we kind of have the same idea again here as we did with G and H, but this looks a little bit uglier because now you have a numerator and a denominator. So let's check out the first one. This entire quantity right here is getting squared. So guess what? Everybody inside the parentheses is going to get squared. The easiest way to tackle all of these types of problems like this is just to do one piece at a time. So I'm going to start with the 2. So take 2 squared, 2 times 2. That's where the 4 is going to come from. Now take x to the third power and raise that to the second power. So successive powers means 3 times 2 would give me x to the sixth. In the denominator, I don't care that it's in the denominator, I'm just keeping track of its location. So y to the fifth raised to the second power would give me y to the 10th, because now it's a power raised to a power. So I'm going to be multiplying those exponents together. Same idea here on J. 3 to the third power is 3 times 3 times 3, so that's where the 27 comes from. X raised to the third power again. If it helps you, put a little 1 up there in the superscript. So x to the first raised to the third is 1 times 3, so that gives me x to the third. And then in the denominator, y squared, again, another example of successive powers. So this would be 2 times 3, which would give an exponent of 6 on the y. So I don't have anything exciting to say for the pattern here, other than everything gets raised to the exponent. Just like we did with G and H, it just happens to have a numerator and a denominator. So for my pattern here, I just have a little summary that I want to go through because, again, it's really easy to do these individually, one at a time, when everything is isolated, but it gets kind of tricky when we start putting a lot of things together. So for our summary, when exponents with like bases are being multiplied, you are going to add the exponents. When exponents with like bases are being divided, you are going to subtract the exponents. And when a base is raised to a successive power, you are going to multiply the exponents together. Tonight, I want you to try the Connect Math homework for 13.1 and 13.2. So it'll be something like, it'll be titled something similar to this. 13.1, 13.2 exponents, and see how you do. It's going to be a little bit of a jumble. It's going to have a lot of the different properties together, and see how it goes. Again, pop into office hours on Friday if you have any questions, and thank you so much for listening.